What's up, y'all? This is section 9.3, variation. Here we go. Variation equation. Well, let's see. Let me just drop this definition right here. It's either a multiplication or a division equation with only two variables and a single number. We call that. It's often called a constant. And if there's a you see a k, that still just represents a number. And this number, this constant, is so stupid important in all of it. I'm color coding it blue. So for the rest of this lesson, that single number that I'm looking for is in blue. Let me show you what I mean. These are all examples of variation equations. Y equals 2x. That's a multiplication or division equation with only two variables and a number. Y equals 2x. Even y divided by x is equal to 3. There's a division, and there's only two variables, and then that's 3. X times y is equal to 5. Check. Everything checks out. And y equals 3 divided by x. These are all multiplication or division equations with two variables and a constant. This is not variation. What is this plus 2 doing over here? No way. If you got rid of it, y equals 3x would be perfectly fine example of variation. But because of the fact that there's plus here, it's not. Same thing here. I know there's only one number, but it's not a multiplication equation. It's an addition equation. And here you've got y equals 3 over x squared. Anything more complicated than just like y and x is going to be not considered variation. This exponent over here of 2 discounts it from being direct variation. It's a separate kind of variation. It's called inverse square variation, but it's not the kind of variation that we're talking about today. There's actually two flavors of variation. They're called direct variation and inverse variation. And so kind of a big deal is just making sure we're like anytime we're working on a problem, we have to make sure, is this direct variation or inverse variation? Because there's separate things that will apply to each. They look differently. Let me go through some famous examples of direct variation equations. So for example here, inches to feet. This is an equation that converts the number of, if you give it the number of feet, then I'll tell you the number of inches. So 0 feet gives 0 inches. 1 foot is 12 inches. 2 feet is 24 inches. 3 feet is 36. 4 feet is 48. All you're really doing is just multiplying by 12. 12 is the constant. 12 is the number, and the two variables are I and f. The constant is 12 inches in every foot. There's an alternate form of this equation, and if you wanted to, you could take the I is equal to 12f and divide both sides by f. You get I over f is equal to 12. And the table still holds. I divided by f is going to be 12. 12 divided by 1 is 12. 48 divided by 4 is 12. They're all 12 when you divide. Notice that when you double the input, you also double the output. So if you had one input, if the input is 1, you double it, you get 2. You're also doubling the inches. Double 2, you get 4. Double this, you get 48. So when you double the input, you double the output. Here's another super famous equation. Circumference of a circle is equal to pi times the diameter. So you have a diameter here, and if the diameter is 0, the circumference is 0. But if the diameter is 1 unit, then this is going to be pi. I'm rounding decimals here, but you could also say it's just pi, circumference of length pi. This is 2 pi, this is 3 pi, this is 4 pi. Notice the constant is pi right here. It's in blue. If you wanted to, you could divide both sides by d and get c divided by d is equal to pi. And the whole doubling thing still works as here as well. If you double 1, you get 2. And you double pi, you get 2 pi. You double 2 and you get 4. Double 6.28 and you get 12.56. Here's another equation from physics. D is equal to RT. Now let's pretend that the rate is constant. You're just putting that car on cruise control and you are going. You're set at a constant rate of 50 miles an hour. If you drive 1 hour, that'll take you 50 miles. If you drive 2 hours, that'll take you 100 miles. If you drive 3 hours, it'll take 150 miles, and 4 hours, 200. An alternate form of this equation is d over t is equal to r. You could rearrange it and get that. And of course, doubling the input, like doubling the number of hours, will double the number of miles. So here's a super mathy version of way of doing this that has absolutely nothing to do with reality. It's just like the general form with no story, with no units on anything. Y is equal to some number times k is equal to x. And let's pretend that k was equal to -2. If we knew that, then we could make a table and we get 1, 2, 3, 4, and we get -2, -4, -6, -8. Rearranging this, you could also get a form of y over x is equal to k. And you can still see, like, -8 divided by 4 is still -2. -6 divided by 3 is -2. -4 divided by 2 is -2. They're all, every y value divided by its corresponding x value is going to give you -2. Now, that's direct variation, and that it works very similarly in all these examples. Here's inverse variation. Let's say we kept, instead of keeping r constant, you see how r is constant here, we're going to keep the distance constant. Let's say we're traveling, we know we got to travel a fixed distance of 100 miles, but we have a couple of different options on how we could do that. We could drive 1 mile an hour, or, I don't know, walk 1 mile an hour, and that would take us, scratch that. If we wanted to do it in 1 hour, the whole trip, we'd have to, like, floor it and really, like, take that gas pedal and just stomp on it for a whole hour. And if we drove 100 miles an hour at that speed, we'd be able to travel our distance. Or we could be a little bit more reasonable and take it in 2 hours. If you wanted to do this 100-mile trip in 2 hours, then you can see you'd need to go 50 miles an hour. If you want to take it 3 hours, then that'd be 33 miles an hour. 4 hours, 25 miles an hour. Rearranging things a little bit, if you want to divide both sides by t, we would get the same equation, d over t is equal to r, but you see in this version we're keeping d as constant. D is the one thing we're not changing, and r and t are changing with respect to each other. When they multiply to each other, 4 times 25, 3 times 33.3 repeating, 2 times 50, 1 times 100, you multiply these together, you always get 100. But as one of them increases, the other one is decreasing. As the time increases, as you allow for more time, that means you don't have to go quite so fast as you're speeding along. So if you were to double the time to go from 1 to 2, you'd actually cut the speed in half. And you can see here, double the time again, you cut the speed in half as well, here from 50 down to 25. That's what inverse variation means. There's still multiplication and division going on, but as one goes up, the other one goes down. Let's say we had areas equal to length times width, and we knew that we wanted a rectangle of exactly 12 square feet, but the dimensions are completely up to you. So you could have 1 by 12 or 2 by 6 or 3 by 4 or 4 by 3. All these, whatever you choose, length times width is going to equal 12. It's just a question of what the dimensions you want. You could rearrange things and divide both sides by L, and you get W. The width is equal to A divided by L. You see this width, if I give you a length, like 4, then you could say 12 divided by 4 is 3. 12 divided by 3 is 4. 12 divided by 2 is 6. 12 divided by this 1 is 12. What's 12 divided by 0? It's nothing. There's no, you can't take a number and divide it by 0. You get an undefined answer. There is no answer. It's undefined. So, and if you wanted to do this 100-mile trip in 0 hours, it's impossible. You can't do it. There's no way you can make a trip in 0 hours. Not even a photon of light could do that. It violates the law of physics, going faster than the speed of light. So that's why there's actually no answer to fill in here. There's not applicable, and division is not defined when you're doing it. So here's an example of inverse variation. X times y is equal to some constant k. In this particular case, we'll let k is equal to 48. And all these rows multiply up to 48, and 0 times what gives you 48? There's nothing. There's no number that can make it equal to x. Is when you know that x is equal to 0, there's no value you could choose for y that would make these two numbers multiply up to 48. It's impossible. So, but if you wanted to rearrange this x, y is equal to k, then you could divide both sides by x, and you get y is equal to k over x. So those are the two flavors of variation we're going to talk about today. There are other flavors, as I kind of alluded to before, but these are the two main ones for today. let's take a look at this word problem. On a given planet, the weight of an object varies directly with the mass of an object. So weight and mass, they're going to be very similar to these right here. If you double the weight, you'll double the. If you double the weight, then you'll also double the mass. If you double the mass or triple the mass, you'll triple the weight. Suppose that an object whose mass is 5 kilograms weighs 10 newtons, and an object who weighs, you want to find the weight of an object whose mass is 7 kilograms. All right, so because it's a direct variation, we can actually set these up as a proportion. If it were inverse variation, we would not be able to do so. But because it's direct, because it says varies directly, we know it's direct variation. We can say 5 kilograms to 10 newtons is going to be equal to 7 kilograms to x newtons. And when you solve this, there's a couple ways of solving it. One shortcut way is to realize that 5 doubles to 10, so 7 should double to 14. X equals 14 is the answer. You could also cross multiply. 5x is equal to 7 times 10. That's another way to solve it. Now, let's flip over, and I will say right now at the halfway point that if you're looking for my middle name, it's actually Benjamin, Aaron Benjamin Bergman. Don't wear it out. All right, so if you're stuck on any of these word problems, and there's a whole bunch of there's like 10 different kinds of problems on variation, and we're going to do a little bit of each. But the big picture, if you're overwhelmed by that idea of doing like lots of different kinds of problems, the one common theme is if you get stuck, if you're not sure what to do, it's probably because you haven't found the value of k. So find that value of k as a first step, and then you'll be able to figure out what you need to figure out for next. It's also kind of handy to know what equations you're dealing with when it comes to direct variation or indirect variation. Because direct variation, we'll use these equations that we've used. You can see they're over here, y equals kx and y over x equals k. Those are the direct variation equations, and then the indirect variation equations are these over here. So, suppose that y varies inversely with x. All right, so we're using indirect variation. With and then y equals 10 and x equals 4. So we can see that I think I'm going to use the inverse variation just because multiplication is a little easier to work with than division. I'm going to use this version. You could do the entire problem using this one over here. I'm just going to start with xy is equal to k. So if that's true, x is equal to 4 and y is equal to 10. I'm going to plug that into here, and then I'm actually able to find the value of k. I'm not getting stuck because I'm finding that value of k. 4 times 10 is equal to k. K is equal to 40 in this particular problem. It might be some other number somewhere else, but right now, right here, k is equal to 40. So therefore, I can type in the equation xy equals 40. That's the first answer right here. Find y when x is equal to 8. All right, so I'm going to move along over to the other version. Right over here, y is equal to k over x, because I know what x is, I know what k is, and if I need to figure out y, it's just k divided by x. It's 40 divided by 8, which is 5. And I'll let you figure out what's underneath the red circle. All right, so here we got a table. We got to figure out if it's direct variation or not direct variation. If it's direct variation, it should satisfy this equation, y over x is equal to k. And we should be able to get the k value 3 different times, one for each of the rows. Y divided by x. Y divided by x is equal to 1.25. Y divided by x. 10 divided by 8 is 1.25. 20 divided by 16, 1.25. It's the same k value all 3 times. It's definitely the direct variation. And the equation would be y divided by x is equal to 1.25. That's the k value. Yep. So if the k value were not the same all 3 times, then I would click not direct variation. Let's see here. I can rearrange this equation. Negative 15y is equal to negative 3x. I can write it over here, and then solving for y, I'm just going to divide both sides by negative 15. And this negative 3 over negative 15 turns into 1/5. Y equals 1/5 x. Yeah, it's direct variation. It's y equals a number times x. That's direct variation. That's this equation right here. Y equals kx. And what is the k value? Oh, k value is 1/5. Let's look at this one. Wait, subtraction? Hold the phone. Get out of here. No way. I'm not doing any math. This is not direct variation. You can't subtract. You can't have subtraction in any kind of a variation equation. Not happening. There's only multiplication or division. And folks, I think that's about it. Yep. Keeping it real. I'm in it right now. Take care, and I'll see you in class.